type of values are they? They're constants. They could be anything. So here's the thing. Does it look like that's a power series? No. Why? Why is it generally speaking not going to be a power series? It kind of looks like it's going to be a power series. I mean, it's the same. Look, how do you get from here to here? You multiply by x minus a. You raise the power, right? But if the constants are different, like 2, 4, 8, 16, 5, 7, are those going to result in a common ratio? No. So the only power series that will be geometric series if all the constants are what? 1. They'd have to be the same. Point being, we're going to look at this specific type of series. X will be in the series. A is what it's centered around. So what we're looking at is what happens to these series when we add them all together. Different things can happen depending on what the value of x is. Different things can happen depending on what the values of x is. So for example, let's just look at an example and go back to that definition. I find it's much more helpful to look at an example and then go back and look at the definition. So this is a power series right here, yes?
Can you have alternating power series?
That's a good question. I'd have to think about that. Not off the top. I mean, I guess so, because there's nothing in there that says the c values have to remain positive.
Yeah,
well, the constants could be negative. Yeah, I guess the constants could be negative, so it could alternate. Yep. So let's take a look at this one. This is a power series. So it's x to the n over 2 to the n. So we're going to look at it in two cases, where x equals -1 and where x equals 3. So if x is equal to -1, if x is equal to -1, what do we end up with? We end up with the sum. These tend to start at 0, by the way. N equals 0 to infinity. Just make note of that, not 1. So you have -1 to the n over what? 2 to the n. Could you tell me what the first few terms are to that series? What are the first, Soma, what are the first few terms? When n is 0, what do you get?
1 over 2.
1 over, what's 2 to the 0?
1.
Yeah, so you get 1 over 1 plus what? Negative, yeah, plus -f. Then plus what?
1 over 3.
Yeah, minus 1 over 8 plus 1 over 16, right?
Yeah.
And what do we know about this sequence? What is this, what type of series is that?
Alternating.
That's an alternating geo, and you know the r value. What's the r value on that? It's just a geometric too. You could just say it is a geometric, but it is alternating too. What's the r value? -0.5. And since the absolute value of -0.5 is less than 1, this what? Therefore it what? Converges. It converges. Nice. Okay, so in this case, for that series, when x is -1, it converges for when x is equal to -1. Theoretically, how many different values could I throw in there? Could I test it for different x values? Sure, but do you have the ability to test like all the x values? Not really. So we have to look at it in different ways. So let's look at 3 here. If we plug in 3, we end up with 3 to the n over what? 2 to the n. Can we rewrite that a little bit? How could we rewrite that to be a little more helpful for us? 3 over 2 to the... What type of series is that? What type of series?
Geometric.
It's geo, and what's the r value? 3 halves. And 3 halves in this case is greater than 1, therefore what? It diverges. So for this power series, when x is -1, it converges. When x is 3, it diverges. So I could ask you to test certain values, but the point is we would really love to know what are all the x values where it converges? What are all the x values where it diverges? Can you do that by just checking one number at a time? No, you don't. So you need a method. You actually have a method for figuring out if a series, you have many methods for finding out if a series converges. One of them is going to prove to be most useful. We'll get to it in 1 second. But before we do that, sometimes you'll be given the definition, the explicit definition, and sometimes it'll be written out like this, and you need to write the explicit definition. Wiley, can you tell me what the explicit definition of this one is? Meaning sigma notation is what I mean. So it's going to be the sum from what to what. I want you to start at 0, and it goes to what?
10?
Well, it's ... so what is it? Infinity, right? And then it's going to be x minus
A.
What is a? And it's 2. And then to some power, I'll leave that blank for now, over something else. Can anybody tell me what the yellow or the blue is going to be? Chip, which one?
The
Yellow or the blue?
blue.
Blue? What do you think the blue is going to be?
Would that be n plus 2 squared?
They're squares. That's good. I like that. N plus 2 squared. Excellent. Yes. Because this is this is 0, that's 1, that's 2, and that's 3. Add 2 and square it. Yes. What's the power going to become on top? Someone else. What's the power going to be on top? Steven, what's the top?
2n plus 4.
2n plus 4. Yep. You double n and you add 4. You double n and you add 4. Does everybody see that? 0 to 4, 1 to 6, 2 to 8, 3 to 10. You double 3, you get 6. 6 plus 4 is 10. Yes, Chip?
Actually,
That. And you found this too. Excellent. And oh, not squared. What do I, negative 1 to the? Yes, very good, because it's alternating. I totally missed that. Yeah. What do you have there? Negatives in there. Absolutely. So you've now written the explicit form. You will need to be able to do that. Wiley, please put your tablet flat, please. Okay, so here is a power series. Here's an infinite power series. It goes on and on and on and on and on. This is, oh, I'm going to go off the highlighter mode here. This is S sub n right here. That is S sub n. Could you write the explicit form of it? Absolutely. Now, what does S1 represent? How many terms are in S1? That means the partial sum with one entry. So what is S1? One term. So what's the first term? Yeah, x minus 1. What's S2? X minus 1 minus x minus 1 squared over 2. It's two terms added together. It's the second partial sum. What's the third partial sum, Annie? What's S3?
X minus 1 minus x minus 1 squared
Yep.
over 2 plus x minus 1 cubed over 3.
Excellent. So those are all the partial sums. And what this graph is right here is a graph of those functions. Is this a function right here? S1 equals x minus 1? Yep.
Yeah.
Is that a function? Sure, that's a function. And that's a function as well. What they've done is they've graphed a bunch of them. S14, here's S14. Here's S5, here's S8, right? What do you notice? There's some common characteristic about it. What do you notice? What's one interesting thing? Yeah, Ian.
They're all equal at x equals 1.
X equals 1, they're all equal right there. And then what about from like here to here? They look
They're all
really
equal,
close,
yeah.
right? They're like bending towards the same thing. But what happens after like that dotted line and after 0? They start splitting, right? It looks like they start splitting. The point is, we want to get an idea of what does this look like when n goes to infinity. So we look at the behavior as you get successively bigger partial sums, right? And it looks like it's going berserk over here. So it's getting weirder over here, and it's getting weirder over here. But what's happening from here to here? It looks like it's converging. Looks like it's converging. So this might tell us something about what x values make the series converge. Based on this graph, do you want to guess what the range of x values are that make this converge? Effectively, I'm asking you for the interval of convergence. Anybody want to guess what it is? Anybody want to guess what the interval is? Yeah.
X equals like 0.5 to x equals 2.
Yeah, so you might go to like from here to here, right?
Yeah.
That could be a guess, right? Anybody want to expand it a little bit?
I said 0.
Yeah, you could maybe say, let's say 0 to 2, right? Maybe guess it, maybe, because we haven't, if we zoom really far in on one of the higher ones, we don't know. So somewhere in there to somewhere over there. This is more hand waving because we haven't done any algebra yet, right? We think it's from like 0 to 2. We think it's from 0 to 2. We need algebra, but that's visually what's going on. So if you kept on graphing higher and higher S15, S16, S17, and what would you look at? You'd look at this region right there and see what's going on. Are they getting closer together or further apart? That's what you'd be looking at. But is that enough to prove what's going on? No, it's not. So there's this big block of text here, but really I want to get to this. What is that from? What is that from? What is that? This one? So this one is summation of what? N equals 0 to infinity of what? Someone new who hasn't spoken yet. Someone who's in. Surely, what's this one going to be? What's the explicit definition of this going to be?
X minus 1 to the n power over n.
Over n? Does that work?
Yeah.
If it starts at 0, it's going to have to be what? You have to be very careful. Like the first one, it is n over here. What's the power here? 1, then 2, then 3. So what's the power on top going to be? N plus 1 up here. Does everybody see why it's n plus 1? You see how it correlates? Because you have, this is the 0 term, but the power is 1. The next one is the first term. It starts at 0, then 1, then 2. We're starting our index at 0. Okay, so if we wanted to run the ratio test on this.
You don't have to make that alternating.
Oh, and it's what? Alternating. Yes, it is. Oh, I keep forgetting the alternating. I don't know what I have against alternating. Oh, I like alternating. Okay, so we're going to do the limit as n goes to infinity. What's the next term? X minus 1 to the n plus 2 times negative 1 to the n plus. We're adding 1 to it. We're adding 1. The next term all over what?
Should I know
Yeah, that's why I'm making it n plus 1. But I'm dividing by the nth term. I'm just skipping an algebra step here, everybody. If I divide by a fraction, that's the same thing as multiplying by the reciprocal. So what do I need to multiply by here? Yes?
The denominator.
Thank you for catching it. This should be n plus 1 as well. You're absolutely right. So what does this become? Thank you for catching that. That's very good. N plus 2. Thank you. No. Yep, n plus 2. Yeah. Okay, good. So what do you multiply by? The current term, but we're flipping it over because we're dividing. Is everybody, are you okay with me skipping that one step? I just don't want to write it out twice. So what does it become? Yeah, we have n plus 1 over negative 1 to the, we can put it down there. It doesn't really matter. X minus 1 to the what? N plus 1. Can we simplify this? Also, what are we missing? It's absolute value of this thing, right? So due to the absolute value, what can we kind of cancel out? Just not kind of, we can actually just get rid of. Yeah, these just go away because it's always going to be positive no matter what, right? Is everybody okay with that? Okay. Oh, I didn't, why am I canceling that one? I don't know what's going on there. That's weird. I'm trying to erase the right thing here and I'm just, there it is. I'll just erase random things and see what happens. Like that. So we actually are canceling that and this. There we go. So what also cancels? The x minus 1, and that cancels. What are you left with on top? You're just left with an x minus 1, right? So the limit as x goes to infinity of the absolute value of x minus 1 times n plus 1 all over what? N plus 2. That right there, you can tell me what that equals. You can tell me what that equals. X will be in the answer. As n goes to infinity, what happens to this? What does that go to? That just goes to 1, right? So what does this whole thing equal? Do you agree it equals the absolute value of x minus 1? Do you agree with that? Nice. For a series to converge using the ratio test, the limit has to be what? For it to converge, it has to be what? Less than what?
1.
Less than 1. So for this to converge, the absolute value of x minus 1 needs to be less than 1, which means what? X minus 1 has to be less than 1 or greater than?
0.
Nope. Negative 1. When you expand it out for absolute value, I add 1 to all three places, and what do I get? 0, x, and hey, did we suspect that was the interval of convergence? We did. This is the interval of convergence almost. There's one last thing to test. Anybody want to guess what we need to test? There's something we have to test. There's two numbers up there. What do you think we have to test? The endpoints. You have to test endpoints. And how do you test the endpoints? Those are x values, so what do you do with these x values? What do you think you do with 0 and 2? Plug them into the original series. Let's look at the original series here. You can just look at this and tell me what's going on. What happens when you plug in 0 on this one? When you plug in 0, when x is 0 on this one, can someone tell me what does the first term become? What's the first term? Negative 1. And what's the second term become? Becomes what? Negative a half. And what's the third term become? Negative a third. And then what? Negative a fourth. And then what? So what is that? That is the opposite of the what? Does that converge? No. So does it converge when x is 0? No. So we keep it strictly like this. Now what do we plug in? 2. So if we plug 2 in, let's go back up here, sorry. If we now plug in 2 on this, Ian, can you tell me what we get when we get 2 there? What's the first term?
1.
What's the next term?
1. Wait. No.
Plug it in there. Plug 2 in. What do you get? Literally plug 2 in. 1/2, yeah. Plus what?
1/3.
1/3 minus?
1/4.
Okay, so what is this?
It's the harmonic.
Careful, it's the alternating harmonic. Does that converge?
Yes.
Yes, so we need to change something here. What do we have to change?
The sign.
This includes 2, right? So another way to say this is it's open on 0 and it's closed. This right here would be the proper interval of convergence. It seems kind of like a small detail to check those endpoints, but what do you think the multiple choice answers are going to look like on the AP exam? They're all going to look really the same. A is going to be like, the first one's going to look like this, or excuse me, they use different. So it'll be like 0 less than x less than 2. B will be 0 less than or equal to x less than 2. C will be 0 less than x less than or equal to 2. D will be 0 less than or equal to x less than or equal to 2. And E will be like Bob. You know, like something out of nowhere, right? Seriously, it'll do that. So do you have to test endpoints? Yeah, usually you can eliminate two. But you have to test endpoints. So basically what I'm giving you today is, here's a power series, run the ratio test, take the limit, set it less than what? 1, and then see what you get. Here's the thing. Certain power series only converge in some places. Certain power series converge for all x values. Some power series converge for no x values, and certain power series converge for one x value. So when you have, this is called the interval of convergence. This is called the interval of convergence. Anybody want to guess what the radius of convergence is going to be for this? It's 1. It's just 1. It's just the distance from the center. So you're going to be asked questions like, what is the radius of convergence? What's the radius of convergence on this one? It is 1 because it's half of the distance from the lowest to the highest. It's a key question. Now, a radius can be anywhere, but it's just saying that's what it is. What happens if it's convergent everywhere? If it's convergent everywhere, what's the radius of convergence? Infinity. What's the radius of convergence if it's convergent at one number? 0. The radius is 0, right? Theoretically, see, 1 dot, how far do you go from 1 dot? Well, you go nowhere. So you need to run the ratio test. Okay, the ratio test right there. Let's actually give you one to try by yourself. Get up to the board. Actually, let's just do group work first. Get up to the board, everybody. Get up to the board and test that for me. Tell me. Write formula. And then what's the second step?
Do the
ratio test. And then what are you going to do? Set limit what? Less than 1, and then solve. Do that and tell me what happened. So what did you find? What did you find on this one? What did you find out?
That the power converges.
Yeah, you found that the limit as n goes to infinity of the absolute value of an plus 1 over an is equal to 0, which is always less than 1. Therefore, it converges where? Converges for all x. The upside down a means for all. So what's the radius of convergence on this? What's the radius of convergence, ROC?
It's
Infinity. The radius is infinity because it's convergent everywhere. Okay, what about this one right here? Let's do this one. Get back to the board. You can work with the same partners. Try that one. On this one, when you do it out, just like before, what did you end up with? You ended up with this. You did the limit, and you figured out it has to be the absolute value of x minus 1 less than 1. So the radius of convergence, therefore, is equal to what? 1. From the center of that interval to the edge, it's always 1. Now, I could ask you, what is the interval? And you would say, yes, x less than 2 less than 0. But what do you still have to test if I asked you for that? You have to test the what? Endpoints. Plug in 0. What do you get? Oh, does this look familiar?
Yeah.
We just did this one, yeah. Did 0 work?
Yeah.
Yes. I think 0 worked. Did 0 work?
No.
No, it was negative the entire time. So this didn't work. But what about 2?
Yes.
2 became the alternating. It did work. So it becomes like that. So the interval of convergence takes a little bit more work. But finding the radius is just going from the center to the edge of the absolute value expression. That's it. Yes, you have to test the endpoints. So yes, you end up figuring out you should get to 4x squared is less than 1, so x squared is less than 1/4. What does that mean? X is between a half and negative a half. But then you have to test your endpoints. You have to test them. So how do you test them? You plug it into the original equation. X is equal to negative a half. What happens when you plug in negative a half into this? It becomes positive 1/4. What's positive 1/4 times 4? 1. It really shouldn't take 5 seconds to get an answer of that question, okay? Clear your mind. There you go. So what do you end up with? 1, 1, and then what do you end up with? 1, and then you end up with? So what happens? It just diverges, right? But what power are you raising that x term to? It's an even power, right? So what happens when it's positive a half? It also diverges. So if I asked you for the interval of convergence, you would say it is negative a half to a half because you tested the endpoints and the endpoints do not work. Write the explicit formula, run the ratio test, test the endpoints. What would the radius on this one be? Mm-hmm. That's correct. Like, that's a good question, Annie. You would need something like write the explicit formula, which is n equals 0 to infinity. What did you have? It's 2 to the 2n, right? Times what? X to the 2n. So if x is equal to 1/2, what do you end up with? The summation of n equals 0 to infinity of 2 to the 2n times 1/2 to the what? 2n. What is 1/2 written in? What is 1/2 written in exponential form? 2 to the what power? 2 to the negative 1. So what is that? 2 to the 2n times 2 to the negative 1 to the 2n. So what is that? N equals 0 to infinity of 2 to the 2n times 2 to the negative 2n. What do you do with powers of powers? When you multiply, you add them. So you end up with 2 to the, what is 2 to the 0? Infinity is 1. Well, is that going to converge? No, because what is that literally? 1 plus 1 plus 1 dot dot dot. So that's infinity. And then you do the same thing for negative 1/2. You could reason out with sentences. That would be fine. That's right there, the algebra. That's all the steps, and that didn't take that long. So you can just gun through that. Go like